We thank Professor Plunk for his outstanding speech. It was truly impeccable, and we all truly enjoyed it. Now, ladies and gentlemen, it is with great pleasure that I introduce Dr. Rahmat Madandoust, a distinguished scholar in the field of concrete materials and technology. Hailing from the province of Guilan, renowned for its lush landscapes and captivating beauty nestled between the Caspian Sea and the Alborz Mountains, Dr. Madandus brings a unique perspective shaped by the natural splendor of his homeland. With a profound expertise in concrete materials and technology, Dr. Madandus' contributions have propelled advancements in sustainable construction practices and infrastructure development. His dedication to excellence and innovation continues to inspire and shape the future of the field. So please join me in extending a warm welcome to Dr. Rahmat Madandoust.
In the name of God. Thank you for your invitation. Hello and welcome everyone. My name is Madandoust and I'm a professor of the University of Guilan, and the area of interest is the in situ testing of concrete. And it's a pleasure to have a chance to present my speech on the topic of assessment of reinforced correction factor for concrete core testing. Well, as you know, concrete core testing is important for determining the in-situ strength of concrete, especially when your cylinder strength is not reliable or some poor workmanship. And also, in safety evaluation of existing concrete, which you need some information about the existing concrete, then you need to go through some in-situ testing. The best and more accurate we can go through the core test is an in-situ test and is a semi-destructive test method. If I could have. Okay. From the literature, core strength does not mean the compressive strength of concrete in a structure for so many reasons. As you see, a number of factors influence on the core strength, such as core diameter, L/D ratio, moisture of condition of the core at the time of testing, direction of drilling, the strength level of the core concrete, and the most important, the presence of reinforced steel bar. Concerning the core size, both ACI and British standard specify a minimum diameter of 100 millimeter, providing that the core diameter should be at least 3 times of the aggregate size. And the L/D ratio preferred to be 2. But in some cases, such as a slab, if you're considering L/D 2s, maybe a smaller concrete core may be deserved. Some standards, like Australia, will give you this to use 75 millimeter core diameter. Some countries like Germany and Turkish, even less than 75, like 50 millimeter diameter. But bear in mind that the core diameter should be at least 3 times your aggregate size. Be aware that if you're taking core with a smaller diameter, you will expect higher variability. That means if you take a smaller than 100 millimeter, then you have to take more sample in order to get a reliable result. And also be aware that small cores are also more liable to damage during the drilling. Now, if you're using a sample with the L over D less than 2, then you have to correct them to convert them to the L over D2. And many standards given this correction factor. Now the question is how good they are. Let me look this figure. Here it is given the effect of core size and length to diameter ratio on correction factor. As you see, the correction factor suggested by British standard and also ASTM is given, and some research which has been done by some investigator using different core diameter like 100 millimeter, 69 or 48 millimeter. As you can see, it seems that ASTM is to be more reliable for a different core diameter. And also I have to mention that some investigators also specify that a strength level also it will affect on your correction factor. So that maybe need to be required to consider. Now, if you're taking core with a steel bar, well, reinforcement bar passing through the core will raise doubt. Neville said, should be awaited. I think Professor Neville is familiar for all of us. He said that should be awaited whenever it's possible. So it is advised to extract core without reinforcement. But sometimes it might be impossible because of the heavily reinforcement region. So you need to take consideration of reinforcing bar in the core. I strongly believed that a reduction will appear on the core strength result. Because rebar cutting leads a weakness in core strength due to the crack which formation between the concrete and the bar. Well, whatever reason you're taking core with the steel bar, ACI recommends. It recommends that the specimen for compression should be trimmed, trim the core to eliminate reinforcement. In other words, it will not allow you to take core with a steel bar. Some code like British Concrete Society, it will allow you to use core with a steel bar, but you need to correct them. And also in the table, some of the standard which will not allow you to use a steel bar, or someone like European or Egyptian will allow you to use concrete core with steel bar, but you need to correct them. Now let's look at the equation which has been given by the British Standard Concrete Society. In this equation, as you can see, the size of the bar and the distance of the axis of the bar from the nearest of the core end has been considered. Now the question is this correction factor reliable? Have all influencing factor been considered? Now, let's see, according to the limited research which has been done by different investigators, let's see what was the result. Considering contradictory evidence has been shown on the effect of the reinforcement bar on measurement of core strength. Someone found no effect. Someone like Goes reported that the presence of the steel bar on core will increase. and someone like Corey reported that various conflicting trends will appear. So we take a comprehensive experimental program to see the effect of the reinforcement on the core strength. We considered a number of parameters. We have listed here core diameter, L/D ratio, moisture condition of the core, concrete strength level, rebar size, and the position in the core. As you know, in most of the time, cores are usually using water-cooled drills. So a core are sufficiently wet, but inside it may be wet or dry, depending on the situation of the concrete in the surface. So, which moisture condition to be considered? Well, different standards give different view. Someone said, keeping the core dry in 7 days. And someone said, soaking for 2 days before testing. Now, for the preparation of the test beam, we took a beam in a width of 300 millimeter, depth 300, and the length of 1 meter. As you can see in the figure, some of them is plain, and some of them has reinforcement. They cured under laboratory condition, and 480 cores were prepared and core specimen trimmed, capped with sulfur mortar compound. 2 strength levels were considered, 21 megapascal and 48 megapascal based on the cube strengths. And the tests were done at the age of 56 days. Here the table gives the detail of the test program in which we performed. Core diameter was 75, 100 millimeter, L/D 1 and 2, bar size 10 and 16 millimeter. The position of the steel bar, some of them considered along the main axis, some of them have deviation. The position of the nearest end was vary between 30 to 75 millimeter. So, I'd like to present the result which we got in this experiment. By the way, for the presentation, I should say that we consider relative strength, which is the average compressive strength of core specimen with the steel bar to the corresponding plain concrete. Also, the effect of a steel bar on core strength shown by different volume percentage of a steel bar in core. Now let's see what we got in these research. First, let's look at the effect of core size, L/D ratio. Here, the figure gives you the variation of relative strength with volume fraction of the steel bar, either for L/D to a 1 and L/D of 2. I should specify that other parameter which has been considered has not been considered here as a variation, and this is because of this scatter as you see. Also, I have to mention, which is important, either in this test and other tests, we found higher scatter in the concrete core strength when you considering core with steel bar. Okay, as you can see, a relative strength for cores for L/D ratio is very close to 1. In other words, if you take L/D equal 1, you will get less effect on the core strength. And this was around 5%. But if you take in L over D equal 2, then that reduction will be up to 15%. That means that the significance will reduce if you're taking L over D ratio of 2. Now let's consider other parameters like core size. Once again, here I'm giving you a variation of the relative strength with the steel volume fraction for two different core diameters, either 100 millimeter or 75 millimeter. Once again, the great dispersion on the test result is due to the ignoring of other factors. Okay, as you can see, core size, both of them, effect on the relative strength for given volume reduction of volume, a fraction of a steel bar. About the difference between 75 and 100 millimeter on the result, about 9% more strength reduction you will expect for 75 millimeter core. So if you take a core diameter lower than 100 millimeter, you need to be looking for more reduction on the core strength with a steel bar. So for interpretation of the result, particular consideration need to be considered on the core diameter. Now let's look at the next parameter, concrete strength level. We consider two strength levels, 21 and 48 megapascal. The variation of the strength level, relative strength, will be given with volume fraction, as I said, for two different strength levels. Here, the L over D ratio was taken 2, and the diameter of the core was considered to be 100 millimeters. As you can see, except for low fraction of steel here, as I'm showing to you, it seems a strength level, the effect of the strength level on the correction, on the relative strength is not very effectable. It seems to be negligible. But at this part, however, this effect is more pronounced for low strength concrete because of the cutting damage as you expected. As the relative strength is increased, it seems that the amount of the relative strength for different volume of fraction is getting constant to nearly to 77%. Okay, now look at the effect of the moisture condition. As I told you before, either considering dry 7 days or soaking for 2 days. Here, as you can see, for each specific moisture condition, it seemed the relative is not significantly affected by the steel volume fraction. But if you compare the effect of the dry condition or wet, you will see the relative core strength were higher for dry as it is expected than to those which is soaked for 2 days. Air dry core was average 9.54% greater than those which has been soaked for 2 days. So that means a relative moisture condition of core should be taken into account when you considering institution in strength of concrete with a steel bar. Okay, now let's look at the effect of the bar size. We took two different bar sizes, 10 millimeter and 16 millimeter. Here again, the relation between relative strength and volume fraction of steel bar is given for these two different size of steel bar. Again, we consider core diameter to be 100 millimeter and the LOD of 2. As you can see from the figure, for a specified bar size, relative strength decreases with increasing the volume fraction of the steel bar. And more important, for a given volume fraction of a steel bar, larger diameter will adversely more effect on the core strength. Also, I have other figure for two different strength levels, 21 and 48. As you can see, for both diameter, relative strength getting lower for higher strength concrete. Look at here. It is more effective for a concrete with low strength, the difference between two core diameter. So once again, I want to specify the effect of bar diameter becoming more evident where you're considering low strength concrete. Okay, now let's look at the effect of distance between the bar axis to the nearest end core. I show with the H. Here, the variation of relative core strength with the steel bar for two different L over D and H has been given. The importance of the factor H is shown on the reliability of the estimation of the core strength. As you can see, relative strength ratio were closer to 1 for H equal 30 compared to the 50. So if you want to be in a case where you considering a reliable result, you maybe take the distance to be as low as possible. The effect of H on a strength variation had a tendency to reduce in increasing by the volume fraction. Now finally, I'm looking to the effect of the bar deviation from the main axis. Here, as you can see, some of the steel bar located along the main axis. And the steel bar is either 16 or 10 as a deformed bar and one as a plane, only for 10 millimeter. And here, as you can see, there is a deviation from the main axis about 25 centimeter, also 16 millimeter and 10 millimeter deformed bar and also 10 millimeter plane. As you can see in this figure, reduction in core strength with rebar, which is offset from the main axis, has been more evident than those core which are without deviation. For 16 millimeter diameter, the steel bar strength reduction for without deviation was around 9.5%, where with deviation this increased to around 18%. From this investigation, it may be concluded core test itself may be reliable, but the interpretation of the result, especially containing a steel bar, can be uncertain. Extensive literature surveys show that different codes give different in-situ strength for a one core diameter, for one core test. Now, based on the comprehensive experimental study, the main conclusion can be summarized is as follows. Concerning L over D ratio presence of a steel bar significantly reduce the strength of the core with L over T of 2. The interpretation of results for two different core diameters deserving particular consideration should be considered separately. Relative strength ratio were getting closer to 1 when you took the distance of H around 30 millimeters rather than 50 millimeters. And finally, symmetric deviation of reinforcing bond from major axis of the core caused a strength reduction up to 18% for such a steel bar like 16 millimeter diameter. The equation given by the Concrete Society, as I show you a number of parameters, it's saying that does not predict the core strength accurately. As you can see, the parameter which has been taken by the British Standard and Concrete Society, just only size of the steel bar and the location of the steel to end of the core. Other parameter has not been considered. And I'll show you that, especially the deviation of the steel bar from the main axis is very effective. I believe the published strength correction factor concerning reinforcing correction factor may not be universally applicable because derived empirically from a specified set of data. Concerning the effect of so many factors in core strength with a steel bar which I present to you, and more scattered on the strengths of the test data, I believe that in such a situation, need to follow ACI approach, trim the core, and to eliminate reinforcement. Thank you for your attention.
Thank you very much, Dr. Madandoust. If there is some question from the floor? No question?
Is it lunchtime? I mean, people is hungry because they don't have any
I've just one question. I didn't understand if your direction of the reinforcement is important or not.
Which one?
I mean, the direction of reinforcement.
The direction of the reinforcement. Well, all the codes, even British, will not allow you to take a core which along the direction of the bar. Those correction factor which has been given by the Concrete Society is applicable if it is on the cross of the core.
Okay, thank you. Okay, you have question, please.
I can't hear you.
Thank you for your good presentation. I just want to know that and be sure that you can hear me well right now. In a reinforcement, when there is a core, we should eliminate it. Then it's not acceptable, right? What I got from your presentation that if we have a core and testing that is reinforcement in that, it's not acceptable.
Well,
and
you take the core with a steel bar, as
yes,
I told you that
yes.
sometimes you can ignore the steel bar.
I see.
But you have to trim them.
I see. The
And
last
take
sentence.
the part without a steel bar. Bear in mind, the part that you take, it should have an L over D ratio of at least 1.
I see. Thank you.
2:30 instead of 2 because we are late now. So at 2:30 we will start the new session in the afternoon. Thank you for your food and prayer and everything. Thank you.